Assalamu alaikum dear students. Welcome to nuclear physics lecture. I'm Dr. Pervez Ahmed. In this lecture, we will talk about nuclear binding energy. So let's start a lecture with the nuclear binding energy of a system. So first of all, we should need to discuss, the general concept of binding energy of a system. What is binding energy of a system? Binding energy is the work done to hold the constituents of an object together. So this is the a more formal introductions for general understanding of binding energy. So let me repeat it again. What is binding energy of a system? So binding energy is the work done to hold the constituents of an object together. Uh, it's also equal to the energy spent while disassembling the object into uh, component parts separated by sufficient distance. This is the for more general understanding, it's also something like a definitions of the binding energy. That is, uh, this is equal to the energy spent while deassembling the object into component parts separated by sufficient distance. If you have an object that has been made from different parts, that has been made from different constituents, so you want to deassemble that particular object. So during that deassembling, you need a particular amount of the energy. So that particular amount of the energy which is required to deassemble an object into different parts, so that particular amount of energy is called as binding energy. If we take an example of an atom, so for an atoms, the atomic binding energy of the atoms derived from the electromagnetic interactions and is the energy required to deassemble an atoms and to free electrons and a nucleus. This is how we define the bonding energy in case of an atom. That is for a special case for an atom. What is mean by the binding energy for an atom? So for an atoms, we call this binding energy the atomic binding energy of an atom, and it's been derived from electromagnetic interactions and is the energy required to deassemble in atoms and to free electron and nucleus. In simple words, in the case of an atom, it's the energy required to deassemble the atom and to electron and nucleus. That is two major parts: electrons and nucleus. So electron binding energy is a measure of the energy required to free electron from their atomic orbits. So this is, something one should differentiate from binding energy of a system. That is, for different objects, the concept of binding energy is though almost the same with some minor modifications. So for the electron, binding energy is basically a measure of the energy which being required to free electron from their atomic orbits. So for a nucleus, we discussed for an electron, but what is the binding energy for a nucleus? So for a nucleus, the binding energy is the energy derived from the strong nuclear force and is the energy required to deassemble a nucleus and to the same number of the free unbound electrons and protons, and it is composed of so that the strong nuclear force can no longer cause the particle to interact. So this is the definition, this is the concept of binding energy for a nucleus. I mean, what is in sample word? What it mean? It means that the binding energy in the case of a nucleus is the amount of the energy required to overcome the strong nuclear force and to separate the nucleus and a different nucleus, that is neutrons and protons. So that's this is the key concept of the binding energy for the nucleus. And in case of a nucleus, we call that nuclear binding energy. In case of the astrophysics, gravitational binding energy is the energy required to explain the material, to expand the materials to an infinity. This quantity is not to be confused with the gravitational potential energy, which is the energy required to separate two bodies to infinite distance, keeping each intact, because the latter energy is lower. So, in other words, more simple words, I mean, how we define the binding energy in astrophysics. So, in the case of astrophysics, we define the concept of binding energy as the gravitational binding energy, and um, it is defined as the energy required to expand the materials to infinity. What it means? It means that this quantity is not to be confused with the gravitational potential energy. What is gravitational potential energy? Gravitational potential energy is the energy required to separate two bodies to infinite distance, keeping each intact. So this is the concept of the binding energy and term of astrophysics. So now let's come toward the point. It's nuclear binding energy. We define the binding energy for different field in physics, different field of everyday life, or different part of science. So now let's come toward the key concept of the lecture, that is nuclear binding energy. So what is mean by nuclear binding energy? So be remember, just like we discussed in a previous lecture, that nuclei are made of protons and neutrons. And we remember the combination of these two, that is protons and neutrons, inside the nucleus, they are called, collectively they are called nucleons, and they are being bound by the strong nuclear force. So let me start again. Nuclei are made up of protons and neutrons, but the mass of the nucleus is always less than the sum of the individual masses of the protons and the neutrons, which constitute it. I mean, this is the well-known fact. For example, we have a nucleus, that is a nucleus of a deuterium, which consists of one proton and one neutron. So if you mass the nucleus atom, the deuterium atom, the deuterium nucleus, so its mass will be less than the separate mass of the protons and neutron. It means that if you have one proton, one neutron separately, you add up their masses, so their mass will be greater than the mass of the deuterium nucleus. So the question is, where the mass has been gone. So the difference that we have in the masses, just like we mentioned in on the above, discussions. So the difference in the masses is basically a measure of the nuclear binding energy, which hold the nucleus together. So what is this? The difference is a measure of the nuclear binding energy, which hold the nucleus together. And this binding energy can be calculated from the Einstein relation, that is nuclear binding energy that you denoted by EB, that is equal to delta mc square. So let me repeat it again, the concept of nuclear binding energy. You know that in case of an atoms, we say that the nuclei are being made of protons and neutrons, but the mass of the nuclei is always less than the sum of the individual masses of the proton and the neutron which constitute it. So the difference that we have in masses of the individual proton and neutron and the nucleus is basically a measure of the nuclear binding energy which hold the nucleus together. So this binding energy can be calculated from the Einstein's famous relations that we call mass energy relations, which is given in this particular case as equal to delta mc square. I mean, this is how you can calculate the nuclear binding energy with famous Einstein mass energy relations. So that's all we have for this particular lecture. See you in another lecture. Till then, bye bye.